Hello everybody, in today's video I will show you how to create your own wood carved pattern inside Rhino and Grasshopper. So let's go together. So you know by now this is Rhino, right? So I just made a quick sideboard so we can actually have a use case that makes sense, right? And then we have Grasshopper. As usual, I already prepared, let's say, the path, and I will walk you through so you can see different examples of how we can actually use that wood carved pattern and how you can create some variations of your own and find ways to play around with it and personalize to your own specific use case, right? So this is just a very basic shelf. And what I did is basically take the front surface and imported it into Rhino, right? So that's that. And then what we basically try to achieve is this carved object, and it feels it's almost like a spherical cutout, but not perfectly spherical, right? So what I will do at the first stage is to just put points onto my surface and then place spheres on those points, and then I will remove those points from my wood volume, and then we will see if that looks like we want it to look or what it looks instead, right? So for that purpose I have the surface, and I start with a grid texture, right? So uniformly distributed points, and then basically could already say, yeah, I mean, with the grid structure, that's how you create these points, right? And you can basically say how many divisions you want. You can make it bigger or smaller, depending on your use case, right? Let's go with this for now. We still have almost 300 nodes, so that's a lot of geometry. So also be careful when you do these algorithms, right? And then we basically plug it right into the sphere node, and then it creates for us like spheres at every single point. And here we can define the size of the radius. So now they overlap. I think that looks more closely to how the carving pattern looks like. And then basically we can already figure it out and see if that is the effect that we want, right? So now we have this, and let's say we move this, we also move this, and now we move up. Now we say Boolean difference. And again, if it's too heavy for your computer, just do it section by section and not all at once. But if you're safe that your computer can handle it, then you can also just run it all together. And then you will see what we get. So also my computer takes some time. Also sometimes it just fails because some weird intersection between the different geometries, right? So then just do section by section, and usually then it works. Or you can at least identify which geometry is failing and substitute it or whatever. So this is now how it looks like, right? It is already like, it looks a little bit like carving, even though it's very uniform like, and almost more like a geometrical grid or whatever. So not exactly what we want, but already getting there. At the top I have a different example, but using the exact same technology or same approach, right? Also the grid, but I think it looks cool. Sometimes you don't need like this natural style, right? But more the artificial, concise, structured approach. Then I think this can be also really interesting depending on the project. And then just another thing that I want to show you while we're working with the grid structure, but it's going a little bit away from the wood carved style, is the following, right? So we have these grids, and then we can use the jitter. What jitter does, it randomly shuffles the list of values, so the order will get mixed up, and that can be helpful at some stages. And like 1 is, let's say, how is it working? 1 is complete random and 0 is no random at all, right? It's all in order. So you can also play with that scale to increase the order level. And then, so if we have our random values, we can split our list at a point. So now we have how many points? 300. So we have to reduce this. So now we split it after 180, and we have all these points, right? And now we go back to our slider for the jittering, and you already see that at 1, so this is the index that we split the list, 183, which is why it stops after that. But then you see, all right, it gets a little bit messed up. Some of these values are randomized. So it looks a little bit more like a gradient or a more natural transition between the order and the chaos. And that way you can really be playful. On 1, it's like completely random, right? As much was said already. But I feel like this can be an interesting mix, going from order to a little bit more chaos, creating gaps. And then you can also play around with the seed. If you feel like this is the level of jitter is good already, but it's just not at the right position. Oh yeah, this must be higher then. Then you can also see maybe you want it in the center, there shouldn't be as much, right? So maybe then you find one seed where it is exactly, yeah, so here, right? So there's now a free space. Maybe that's something you need for manufacturing or whatever reason. So then you can just use this one. And then we do the same thing again. We just place spheres on these points, and because they are like ordered at the front and more chaotic at the back, you get a very different approach or appearance. And let me increase the radius still, and then bake it, group it, yes. And then you will also get like a really interesting result, if you ask me. Okay, so we do the same thing again, right? We do Boolean difference, then we select our group, and then we have to wait. And then this is what we get. I think it's interesting. You see more of the base shape, right? Because sometimes it's just the sphere that's popping out instead of these rectangular carved sections. What I usually do then, I start like this, and then I make it a little bit thinner, so it's not as brutally carved in, but more smoothly. I mean, you can also just adjust the radius from the start, but I feel like this I have a visual way to control it. And at the top you see there's like a different kind of approach to this whole thing, where I kept the radius to be smaller, and we get this almost braille like blind people kind of writing style, which I think is really cool. And it's nice, this adding this randomness. I think this is actually quite interesting. Also this transition thing, right? But let's go back to the original intention of doing the wood carving. So maybe it's not the best idea to start with a ordered grid of points, because then we get a really artificial appearing thing, right? So what we do instead is we take our surface, and then we want to populate it with points. In order to populate it with points, we have to provide a region where to populate it. And that's why I use the bounding rectangle, right? Which basically just draws a rectangle around your surface. And then, because my surface is oriented in space, like in this plane rather than on the usual X, Y plane, I have to also indicate that please look at the YZ plane instead, and also use the X-axis as the orientation, right? So then we have our rectangle in the right space. If you're not sure, just play around with it, or just put your target surface in the orientation of the base plane, like of the space, right? XY, the very normal standard one. And then it usually works from default. But now, because of my settings, it just creates this really tiny little rectangle, which is not what we're looking for. So I will go back. So yeah, there we have it. And then with that region, we can finally do a populate 2D. And now you already see that these points are populated randomly by default. You can just switch the number of points, how many points you actually want to put on there. Something not too crazy. You can say, again, change the seed. And if you already have points that you want to have on that, you can already add them to the list, right? I rarely use it, but actually could also be interesting to have some structured grid points, right? And then the population, so you get the same effect as we did before with the jitter. But anyways, so then on these points, you can already do the same thing as we did before. You can just take your spheres, and I see that we probably need more points, so we don't have as many gaps, because they stand out a lot when we do the Boolean operation afterwards. So I think this is more like it. And just a constant radius, right? And then we get, like, I think already something that looks pretty accurate. So at this stage, we can bake it again. I will demonstrate. And try to move it not beyond the center line of the sphere, because then you get some weird volumes, right? So rather one-sided. And then we do Boolean difference. And then we have our carving pattern. I think this looks already more like what we want, but because of the spheres, it still looks a little bit unnatural or fake. So that's where now the scale non-uniform comes in, right? So what it does is that we can basically go back here, and we have our spheres, but we can scale them in certain directions instead of uniformly across the whole thing. So for this example, I scale them across the x-axis, which stretches them, and we get this ellipsoid instead of the sphere. And I think this will create a much more convincing wood carving appearance. So let's do exactly the same thing. So right, the position of the spheres is exactly the same, right? All I change now is the scale in the x direction. And I think you can already more or less see the effect. Boolean difference, select a group. Right, and I think this looks pretty much like what we're looking for. It's very nice because it's non-uniform. You have a sense of directionality, right? Like somebody carved it from that side to that side. And you have all the control. You can now adjust the scales. Also, if you feel like, this is too wide, you want it smaller, you add points, right? So you have all the control to customize this wood carving to your desires. Let me just do what I did with the others, so it's not as brutal. I think this would actually be harder to do in real life, but I like it a little bit more subtle, like some subtlety in there. And now I want to show you just some additional ways to create variation and take control of your wood carving. Maybe it goes away from the original or it adds to it, but at least I want to give you some tools to further explore the realm of the wood carving. So not every single design looks the same with the wood carving pattern, right? So what can we do again? We can, for example, randomize stuff more. So the first thing that I would do is, if we have our spheres, maybe they're all now perfectly oriented in the x direction. Maybe we want to rotate them. So I use the rotate command and I apply a random rotation angle, right? So I create the random list with 100 entries, or actually so my population has 162. So I could either take this input and plug it in here, or if I don't want to go all the way back, I can use the list length and it will give me a single input, which is the number of items in the list. And because then I can also change the parameter here, and it's not fixed to 1, but it will also adjust accordingly to whatever population I have here. So I plug it in, I get exactly that amount of random values in my list, and I define the range to be between 0 and 1, I mean, because here the angle is in radians, right? So it's multiples of pi. So 2 pi is basically 360, so a single pi is 180, and half a pi is 90 degrees. So if I define from 0 to 1, I can basically say that please rotate from 0 to 180 degrees, but don't go beyond, because then we basically already covered every direction, because it's still symmetric, this ellipsoid, right? So if you rotate it that way, it doesn't matter to rotate it even further. Anyway, you can, with this input, basically restrict the amount of rotation that you want to apply. And then you still have to define the plane. And because, again, we have this vertical orientation of our surface, you have to figure out which plane is the right one. And I just plug then in the points, say your origin is now the XZ plane, and then the rotate command also works. And here is what you see, what you get, right? It's a combination of the random and the rotation. So some ellipsoids are rotated more than others. So you get a really wild mix. And I think maybe this is too dramatic. We can also change the range to like degree, right? And make it different that way. But maybe let's say just 0.5. So it's only 90 degrees max. And then the rotation looks a little bit more uniform, but still has some randomness. So if we use that as the example, you can already see that it looks a little bit different. All right, so that's what we get now. So compared to the one below, let me just push it aside so there's not as much shadow, right? You see, okay, let's also make it a little bit flatter so it remains comparable in a sense. That here we have some outliers, some that go really like 45 degrees and some that are more in between 45 and 90 and some that are actually 90. So it's a little bit more of a natural flow rather than strictly one-dimensional, right? And also you get these sections that look like they're a little bit longer and belong together instead of very separate ones, right? So I think that's also a cool one. And then we can take the whole thing a step further by randomizing not only the rotation, but also the scale, right? So we have another random, and we say, so if we ignore these ones, right? So we take our rotated ones and we scale them non-uniformly again in X and Y direction by a random list. And the scale can vary between 0.7 and 1. So this is the domain that I constructed to give as input for the random list. So all the random values are between 0.7 and 1, and we can adjust it with the slider still. Right, so I copied the random list and applied a different seed, so they're not exactly the same. So in X and Y direction don't always scale in the same amount, right? So now with different seed, every single sphere will have different values for both X and Y. And then we get like, let's see, we get these guys. So if you compare it to before, or maybe instead a better view. So this is where everything is the same size, and this is, and now let's, just to make it a little bit more obvious, right? You see what happens, that some are really small, some are really big. And I think that can be interesting, but also it looks less like the natural wood carving design, right? So be aware that you might deviate from what you aspire to achieve here, but still, I think a funny little twist. And let's just have a look how that looks on the actual thing. So now if you look at it compared to the others, you see that it has a little bit of a different dynamic. It's like some things were done with a different tool, or they're a little bit out of place here, while others are really long and deep and wide. So I think just a funny little twist, right? Do with it what you want. And then the last one, which is basically trying to do the same thing as we did with the jitter for the uniform grid, but still for the random population of points instead, right? So I have my points here, random, and I just take one of these points. For me, it didn't really matter. Just for the sake of this example, I just picked the first, and then I pull all these points to that point in order to get the distance, right? So now I have all the distance values from all the points to my chosen point here. And these points I will remap and do the graph mapper thing that we usually do, right? So I take my distances, say, remap all those values to be between 0 and 1, right, relatively. Then I feed it into the graph mapper, so I have control over the transition between those values. I remap again because my radius is actually supposed to be bigger than 0 and 1. So I construct another domain. You can also do it here, just adjust the domain, but I like to keep my graph mapper in the default style and not playing around and just applying a different domain afterwards again. It's easy, you can just copy the components and that's it. So I construct another domain. So they will range between 2.1 and 3.1 in this example, the radius of my spheres, right? So let's see, I have my points, I put spheres on there, and the radius now is defined by our curve and our domain. So it's between 2 and 3, and you see based on the distance to our point, the radius increases, right? So when we can, by adjusting our curve, we can also make the transition less smooth or more smooth, right? So now it's not so smooth. Now it's more natural, more slowly, gradually. And then we can also, just by changing, I don't know, the index. So our point is now at a different corner. We can also flip the whole thing. And let me just, okay, let's do front again. So you see it better. And now if you change the index, another point is chosen. And maybe we also have a point. So this one seems to be more to the left again. So now there's a point somewhere in the center. And now and the left and the right are bigger than the center. I think that's really interesting, right? So, okay. And then you can basically take these spheres or you scale them again. And I have the non-uniform scale here. And the Z value is constant and the X value, the X value is based obviously on our graph mapper. I was a little bit lost in my own algorithm here. So let me just show you how that works. I mean, the effect is visible a little bit, but it's not super strong, right? We could have been more extreme with our domain. Let's reduce the amount of points and then increase the size. Okay, and now let's have a final look at how this potentially looks like. I think the idea is pretty cool that to the sides, we have another transition than in the center, where we can indicate some movement or meaning in our design by using patterns that are dynamic and that indicate something beyond the norm. See, like in the center now, I think it's pretty cool. So in the center we have more on point, and to the sides it gets more stretched. So I think this is really cool. And at the top there are just some other examples that I created with the exact same algorithm, right? Just to test things out. So you also see that there's so much variation that you can apply. I hope you enjoyed this tutorial again, that you have a better understanding about how to work with your Grasshopper components, that you're able of creating your own custom wood carving design for your project. Thank you for tuning in. Please like and subscribe if you're interested in more of this kind of content. Let me know. Thank you.